Okay, so today we will see what is this Docker desktop on Windows, and let's continue with Docker containers. Okay, so Docker desktop, it is an application that gets installed when you install Docker on Windows and Mac. Okay, in which on Linux we don't have any graphical user interface, so you will not see this, this application. But if you install Docker desktop on Windows and Mac, you will get this user interface. Okay, so if you check your, this this bar. So here you'll have this application, okay, called Docker Desktop. So where you can see all your containers, images, volumes, builds, okay, Docker scanning tool like Docker Scout and any other extension. So you can see everything here. Okay. So if you're learning Dockers for the first time, I highly suggest you use Docker Desktop so that you will easily understand various commands, how to see information about the images, containers, volumes, and all those things. Okay. And here you'll have the settings. Okay. So there are general settings. You can also enable Docker daemon to listen on some TCP port. Okay. And, you can also set how much CPU and memory this Docker desktop will use. Okay. So there are some, default configurations like 8 GB CPU and 2 GB memory will be used by your Docker desktop. And also, there are some configurations related to Docker daemon. Okay, you can change it here and then restart. So Docker daemon will restart with your updated configurations. Okay. And coming to Kubernetes, so you also have Kubernetes. Okay, so if you just enable Kubernetes and restart Docker daemon, so it will create a single node Kubernetes cluster. Okay, so you don't require any Minikube or any other things if you run Docker desktop. And there are some extensions. Okay, yeah, so these are the various options you have. And also there is something known as proxies in case if you want to use proxy server to redirect your request. So there are some configurations related to proxy as well. Okay. So these are the various configurations you have. And now once you come back to the main page, here you'll have all the images that you download. You can see the image name, tag, the size. Okay. So like if you want to create a container based on this image, you can directly click on this run command. So it will automatically create a container. Okay. And also there are some, options like pull the image and view all the packages inside it. Okay. So we'll see when we talk about, security scanning your container images, we'll see that. You can also delete your Docker image. Okay. So you have your usual command line commands like docker rm, docker image rm, or docker image, docker rmi command. Otherwise you can simply click on this delete command, it will delete this image for you. Okay. And you have the hub here. Okay. So this is Docker hub. Once you click on sign in, okay, so let me show you, see if I can sign in. So once you sign in, all your Docker images that you uploaded to your account will be visible here. And this is for the artifact. Okay, so this we don't require because we don't use any artifactory. Let's see if it is. Okay, so once you log in, right? So all your images will come here. Okay, you can see here all my images came here. Got it? Clear, guys? Hello.
Yes, clear.
Okay, and you have your containers here. So currently there are no containers. Okay, and then you don't have any volumes. You can create volume from here and then use it for your container. So these are for the Docker builds. Docker dev environments, we won't use it. So this is Docker Scout. So this will basically scan your Docker images. Okay. So we will see about this Docker Scout later, not now. We'll also see Try-V scanning tool. Then we'll come back to, Docker Scout. Okay. So this is about Docker desktop. Okay. The same is true for Mac as well. There is no change in the UI and the options. Everything remains the same. Okay. Now let's talk about working with Docker containers. Okay, so since there are a lot of commands related to Docker containers, okay, so we'll split them into two parts. Okay. Now, how do I find out all the commands related to Docker container? Okay. So when you do Docker container hyphen hyphen help or Docker container help, you're going to get all these options. Okay. Like attach, run, stop, start, ls, kill, exec. Okay. So there are a lot of commands. So covering them in a single is not possible. Okay. So we are going to cover them in couple of sessions. Okay. So when you're running a Docker container, okay, so what are options you can give? Okay, so there are plenty of them. Okay, so like you can name a container when you're running it. You can run a container either in foreground or background. Okay, you can expose a container port on your machine. Okay, so I'll tell you what is that expose and why we use. Okay, and then you can supply some environment variables when you're running it. Okay, so once you have a container running, you can inspect it. Okay, you can also use some volume mappings when you are running the container. You can check all the processes running inside the container. You can check the resource utilization, like how much of CPU and memory is being utilized by the container. Okay, you can attach to a container. You can detach from a container. You can pause a container, unpause, stop a container, kill a container, delete it, check all the logs of the container. Okay. So you can start an additional process inside a running container. Okay. Let's say a container is running with some process. Okay. I can go into the container and start additional process. Okay. I can decide when a container should restart in case if container fails. Okay. I can also create an image, Docker image out of a running container or a stopped container that is also there. Okay. So there are plenty of options that you can, use while running the container, and then you can check the statistics and various other things after a container is running. Got it? Clear, guys?
Yes.
Okay, but what exactly is a container? What exactly is a container is? So we'll spend some time before going into Docker containers on uh, understanding some basics of containers. Okay, so what is a container? So what will a container have? Hmm? So basically, container is an instantiation of a Docker image, right? Okay, if you have a Docker image, you can create a container out of it. Okay, correct? Then uh, what are the processes run inside the container? Why we containerize? Okay, so basically a container should run at least one process, right?
Right.
So this process can create another other processes, but we will not go into that now. Okay, so container means it should start at least one process. Okay, so without which you cannot say that the container is in the running state. Okay, if there is no process running, the container, when it start, immediately it goes into stopped state. Okay, there should be a process running. Okay, always. Okay, because your application should run always so that your container will be in the running state. So whatever process that you're running, it can be anything. Okay, so let's say I run a Java application, Java-jar, and some name of the jar file. So this is an ever running application. Okay, so this becomes the process inside my container. Okay, so it can be anything. Let's say sleep 1,000. Okay, it may not be ever running process, but this process will run for 1,000 seconds. So which means my container will be in the running state for at least 1,000 seconds, right? Okay, similarly, there should be some process running inside the container. So whenever you're creating your own customized Docker images, okay, you should define the starting process of the container. Okay, so when someone uses your image, so what will be the starting process? So when they run a container from your image, okay, so what should be the starting process that you define inside the image? Clear?
Right.
Got it?
Yep.
Any questions? No, right?
Understood.
Okay. So now we understood that there should be a process. Okay. Like how those processes will be defined. So this is again advanced. So we will again talk about it in Dockerfile sessions, but I wanted to give you some introduction. Okay, so that you will understand the container images better. Okay, so there are two terms that we use. Okay, when we define the starting process of a container. Okay, so we use these two commands to set the starting process. Okay, so we call it as command, or we call it as entry point. Okay, so both can be used to define. Okay, let's say I wanted to run sleep 3000 as the starting command. Either you define it with cmd or you define it with entry point. Okay, so where do you find these two? Okay, when you inspect a Docker image, so Docker image, inspect the name of the image. Okay, you will find either CMD set to some value or entry point set to some value. Okay, so you will not have multiple, you cannot have multiple CMDs. Okay, you cannot have multiple entry points. There will be only one. Even though if you use multiple CMDs and entry points, the last one will be considered. Okay, so now that we understood, it will be either CMD or entry point that decides the starting process of a container. Okay, so can I have both? Yes, you can have both. Okay, so when you have both, they cannot use the same instruction like sleep 3000 something. Okay, so when you use both, the overall command should be broken into two pieces like this. Okay, it's like entry point, I'm calling it as sleep, and command, I'm calling it as 3000. The reason why I've split in this way is when you have both CMD and entry point defined in an image, the final command will always be entry point space the CMD, which means when I set entry point as sleep, CMD as 3000, your final command will be sleep 3000. Got it? Clear, guys? Here the CMD is being used as an argument to the entry point. Okay. So when you want to use them together, always split your command so that you know your entry point will have your actual binary or something like that. And CMD has some arguments. Okay. So what let me explain with one more example. Let's say the command I wanted to use is running a some jar file, something like this. So I know that the command is java-jar demo.jar. Okay, so how I will split among CMD and entry point in this case is I will set entry point as java-jar and CMD as my demo.jar file. So now the overall command becomes java-jar space demo.jar. Okay, clear, guys?
Clear.
Okay. Now the question comes is, so we have so many public Docker images. Okay. Like we have Python, we have Go. So there are a lot of images we have. Okay. So let's take the case of a simple Python image. Okay. So here these images are not at all useful because these are not customized for our application. So these are used so that these are available so that when we create our own Docker images, we can use them as base images, and then we can create our own images on top of these images. Okay, that's the reason why we have. So when you look at these images, okay, when you inspect these images, so mostly they'll have CMD, okay, or entry point. Okay, so since they don't have any actual application process to run, mostly what they will do is they'll try to print the help section, something like this, or Python hyphen hyphen version, some generic commands they will just mention as part of CMD or entry point. Okay, clear? That's the reason when you just run these images as containers, in most of the scenarios, you will see that the version of their application. Python or something. So their version will be printed onto the console because they'll just set this as a starting process because they don't have any application to run. Okay. Now the question is, can you override? Okay. So let's say you have a custom image or it is a standard image from Docker Hub. Okay. So it is using CMD only, or it is using entry point only, or it is using CMD plus entry point both to set the starting instruction. Okay. So when you have those images, okay, so can you override when you run them? Can you override the CMD? Yes. Can you override the entry point? Yes. Can you override both? Yes. It is always possible. Okay. It is not like you defined starting process and you cannot override it. Okay. You can override it. Okay. So should you build a new image for overriding? It's not necessary. Okay. While you're running an image as a container only, you can override. Okay. No need to build a new image. The reason why this is required is, let's say in future, so instead of running a jar file with name demo.jar, you might run a different jar file with a different name. Okay, then you create a new Docker image with a new CMD instruction with a new name. It's not necessary. When I'm running my container itself, I'll try to override the CMD while keeping the entry point as it is. Got it? For example, okay, let's say I have CMD as 3000, sleep entry point as sleep. Okay. Now when I run my container, what will be my final command? Sleep 3000, right? Correct?
Yeah.
Yes.
So I want to change the CMD to 5000. What will I do?
Inspect, Docker inspect and
No, that
change.
is no. See, Docker inspect, it will just show you the information. You can't edit the image like that.
Okay.
So when you
Okay.
run the Docker image, you can supply whatever values you
Yeah.
want.
So when I run this container, when I run the container which has the CMD and entry point, so I can override the CMD and I can set it to 5000. Okay. So let's say I don't need this sleep 3000. I need a ping localhost. I want to ping a localhost. Okay. So when I'm running this as a container, I'll override this entry point and set it to ping, and the CMD I'll override it to localhost. Because my final command will be entry point plus CMD. Okay, it will be ping localhost and not the default sleep 3000. Okay.
Question.
Okay.
Is CMD and entry point mandatory to be included in the image?
Yeah, correct. Okay. But mostly you will not, face this issue because, okay, any custom image that you create, okay, always includes a base image. Okay. Got it?
Yeah.
Like I can take Golang based image, OpenJDK or Python, okay, as a base image, and on top of it I'll start adding my own logic, correct, to customize my image. Okay, whatever CMD and entry point which are available in the base image, those will be considered in the final image if you don't mention your own CMD and entry point. Okay, so they will be taken from the base image. Okay, and without any base image or anything, you can't build your own image. So which means you ideally will not face any issue with CMD and entry point. They will always be taken from the base image unless you override in your custom image.
So one question here. So let's say I don't define a entry point and a CMD in my image, but
Mm,
I'm using a base image. So if I run the Docker inspect command, I'll see
mm.
this entry point and CMD from the base image, right?
Yeah, correct.
Okay.
Okay, so
So
there
what
won't be
if,
any differentiation like it is coming
okay,
from base image or it is coming from your own custom image. You can't
okay,
differentiate it.
okay. What if I include my entry command, entry and command inside the image?
Then
So there'll be
yours will be
one in the
shown.
base.
No, no, no.
Ours. Okay,
Yours will be
okay.
shown. There will be only one CMD, only one entry point.
Okay, got it. Understood.
So Vikram, Docker inspect information is common
Yeah. So Docker image inspect will give you information about the image. Okay.
about the.
So if you create your own custom image on top of the base image, the information will be, combinedly shown for the image. It is not like you are using this base image and this is the CMD and entry point for that, and this is your overridden CMD and entry. It won't show anything like that. It will show image as a whole. I'll show you. Okay. Okay, let me first show you. Let me first see if I have any images in this machine. Okay, so I'm running on Windows. I'm not spinning my EC2 instance for today. Okay, so I have a lot of Docker images. Okay, so let me just inspect this image. Okay, it says Spring Maven app with tag as 3. Okay, so Docker image inspect. Okay, let me do one thing. Let me open Git bash. And then the tag is 3. Okay, so if you see, um, I have information about the image. If I scroll, so these are the environment variables which are already available in the image. Okay, and if you see CMD is null, there is no command. So what they have done is they have kept everything in the entry point only. If you see entry point, it is Java hyphen jar, and then they are simply running a jar file and giving some extra arguments because the developer knows how to run application. That one becomes the entry point, or that one becomes the CMD, or you can have both. And you have extra information like for what architecture this is built, it can run on which operating system, and all those things. Okay.
Okay.
Okay, so this is about um, your image, like inspecting an image. You can't edit that inspect and then expect the new image to be created. It is not like that. Okay, now coming to the commands related to Docker, so there are plenty of them. Okay, so you can't just cover them in a single day. Okay, so you have various options, and then when you're just running a container, they will simply fail. You need to know why they failed. Okay, and all those things. So let me first get the help section, Docker help. So you have all the commands. Okay. So there are other commands that you see here, like um, Docker scan, Docker sbomb, Docker scout. So these are some newly added commands. The reason why this is required, these are added is because Docker now has its own container scanning tool. Okay. For that, they have the Docker scout, and Docker scan is deprecated and it is replaced by Docker scout. We will see this as well. Okay. And coming to the containers, we have the main command, main management command, that is container. So let's check the help section of the Docker container. Okay, so you can basically run a container. Okay, so when you do Docker container run, it will create and run. Okay, otherwise you can first create a container. Okay, but it won't be in the running state, and then you can start the container. Okay, so this is an indirect process which no one uses. Okay, you can simply do Docker run, so it will create and run a container. You can stop a container, restart this container again here, and see all the processes running using Docker container top. See the complete statistics like CPU and mem usage using stats. Okay, you can use copy CP to copy files from and to the container. Okay, you can check the logs of the container, list all the containers, stop a container, kill a container. So there are plenty of options. Okay, now see how to basically run a container. So we know that using
Yes.
Docker container run,
So Vikram, this copy is from host to container or container to container?
both, it's to and fro. Okay, we'll see that as well. Okay, so when you do Docker container run, so basically it creates a container and runs it from a Docker image. Okay, so there are various options here. Okay, um, like we don't require all of them. So hyphen detach is one which we will use. The reason why we use hyphen detach is by default when you start a container, it runs in the foreground and it will block your terminal. Okay, you need to start a container in the background mode always. For that you have hyphen detach. Okay, and then you can supply environment variables which we will see later. Okay, you can start a container in the interactive mode. Also you can attach a terminal using hyphen t. This is important. Attach some volumes using hyphen volume. And there are plenty of things. Okay, you can publish all ports or you can publish individual ports. So what is meaning of this publishing, I'll explain. Okay, so rest of the flags we don't require. Okay, it again depends upon our requirement. Okay, so let me first just explain
See,
a basic.
Vikram, volume is from Docker sense or OS sense, the base OS sense.
No, that is from Docker only.
Okay. So how is it different from the OS level volume?
So we did not even come to the Docker volumes yet.
Okay. No, I know that, but you just explained.
Yeah, so I'll
Fine.
come to it. So
Okay.
Docker wall.
Fine. Okay. Okay.
Okay,
Fine.
so Docker container run. Okay, so the syntax will be, as you already said, as you already seen. So here, Docker container run will simply start a container, but this requires an image. Okay, so if I simply say nginx latest, so what this is doing is it is creating a container. Okay, from this nginx latest image. Okay, so here we are not providing any name to the container, any volumes, any ports, any detached mode, nothing. So we are simply running this container using Docker container run nginx latest. Nginx latest is the name of the image. Okay, so let me just click and press enter and see. Now you can see here your container started. Okay, and it is actually displaying its log on the terminal. So I'm completely blocked on the terminal. Even if I press anything, I can't do anything. Okay, because we are actually running this container in the foreground mode. You can also say we have attached to the container. Okay, we can't do anything here. Okay, so then what should I do if I simply press Control C? So what is happening here? It is exiting, right? But what exactly we have done when we pressed Control C? What did we do?
Yesterday
So this is
CICD
the
or something.
process running inside the container. So when we did Control C, what we actually did is we stopped that process. So which means indirectly we killed this container. Okay, because it is running in the foreground and then we interrupted that process. So it interrupted the container. Okay, so in order to understand that, let's first list all the containers. Okay, so if you just check the help section of Docker container help, you will see that ls is the command that we use to list all the containers. Okay, so Docker container ls, but this is a very long command and you don't have to use it. So there is another command called docker process state, docker ps. Okay, so this is much better. So Docker PS will only show you the running containers. If you want to see the containers which are running and which are also stopped, always use -a, which is short for all. Okay. Now you will see the container which I just started before from the Nginx latest image is in the exited state. The reason why it is exited state is you started the container in the foreground so that it is showing the process information to you and all, and then you interrupted the process by simply pressing Ctrl C on the keyboard. Then you killed that process, so it killed the container. Okay. Not only that, you should know other information about the container here. When you start the container, Docker will assign a container ID. Okay. This is the container ID and also a random name. Okay. So which one you can control is you can give your own name, but container ID will be auto-generated. Okay, when you do docker ps-a, it will show both running and stopped containers. Okay, all the container will have a ID. They will start from an image. What command they are running, that will be shown here. So when it is created, what is their actual status, whether they are running or not, everything will be shown here. Okay. Now what I'll do is I'll run the same command like before, but this time I'll try to start it in the background mode or the detached mode with -d. Okay. Now it started in the background mode. Whatever data that that you're seeing here is the container ID. Okay. So if I do docker ps-a, okay, you can see FA77, FA77. So that container ID is printed. But this time the container is in the up status, up 9 seconds ago. So forget about this port mapping and all. I'll come back to later, and a random name assigned to this. Okay. Got it? So can you control this naming? Yes, I can control. So let me create one more container. Okay. So this time I will try to name it. Okay. Hyphen name, and I'll call the name of the container as web. Okay. See here this hyphen name, followed by the web. So this is actually, how you pass various options. Okay. So let me just clear one more thing. So here I've used -web here. So can I use it after run? Yes, you can use it after run. After that, you can set the daemon mode, or else before you can set the daemon mode, after you can set the name of the container. It's not mandatory. Okay. So here only thing that you need to make sure is, so whatever these options that you're putting, you should put between Docker container run and your image name. You can put all the options in between. Okay. But don't say hyphen name, that is you're naming a container as web. Just cut the web and put it here. It won't work like that. So if you're using a flag, the value that you're assigning to the flag should be adjacent to that particular flag. Okay. And -d is the short of hyphen detach. Okay, you can use hyphen detach or -d. It is up to you. Okay, so now what we are doing, I'm just naming the container as a web. Okay, again, some container ID is printed. So now docker ps-a, you will see you have a container web. So now I can easily know which container is web container or any other container because I named it. And now the real issue. So when you already have a container by the name web, if you try to start one more container with the same name, Docker will throw an error saying that the container name web is already in use. Okay, you can't use same name to two different containers. Okay, so that is one thing you should know. Got it? Any questions? Okay. So now we know that this is the basic command to run a container, and docker ps-a is used to list all the containers. So how do I inspect a container? I want to know more information about the container. Okay. So we know docker image inspect. Similarly, you have docker container inspect. So docker container inspect, you should give the name of the container or ID of the container. So container gets two identities. Either you can use the name or use a proper container ID. Okay. Like I can inspect this container by using the name called web or using the container ID 1CB. Okay. You don't have to use the whole ID of the container. First few unique characters, like first 4 characters, like ICB2, it's sufficient. Okay, because Docker knows which container to take. Okay. So here we are inspecting this Nginx container. You can see the state of the container. It is in the running state. Okay. Status is running. Exit code is 0. Okay. And it is running a process. Let me scroll to the bottom first. Okay, so this is your environment. Okay, and this is your CMD, which your your Nginx is running. Okay, entry point is this. Okay, now if you see here, we have both entry point and CMD. Okay, and network settings. So every container, we'll see this in the networking. Every container gets an internal IP address. Okay, so if you go to container networking settings, see here you will see the IP address that is assigned to the container, that is 172.17.0.3. Okay, every container gets the IP address in this range, and this is the default bridge network. So this is coming from the default bridge network. Of course, you have to wait till the Docker networking session in order to understand this bridge networking and all. Okay, so this is information about a container. If anyone asks you how do you get information about the container, like you know what is its IP address, what is its state, what command the container is running. So you need to inspect. Inspect is the only command. Got it? Any questions?
Oh, it is like a log file, right, Vikram? Inspect
No, it
log
is not
file.
log file. It is not log file.
Okay.
It is information. So I'll come to the log file. Okay.
Okay.
So using Docker container logs or Docker logs, you can get all the logs. But there are some special use cases we have to see, okay, and understand, okay, before diving deep into containers. So let me fetch all the, information about the containers, all containers running and stopped. Okay, if I want to remove, a container, okay, so the ideal process is to first stop it and then, just remove it. Okay, otherwise you can force remove it using kill command. Okay, so that is one more option you have. Okay, so let me show both. So let's say I want to remove this container. Okay, so I can use Docker container. Okay, so first there is this stop command. So this will stop a container. So what is the container that I wanted to stop? I wanted to stop this web container. I can either use web or I can use the container ID. Anything is fine. Okay, so first you need to stop it. Okay, it stopped. So I can just go to ps-a. You can see that web container, it is in the exited state. Okay, and then once a container is stopped, I can remove it using rm. Okay, Docker container rm web. Now the container gets completely removed. Okay, so there is a short command called Docker container. Okay, uh, rm. Okay, so if I use rm and then, so let's say I want to delete this container. Okay, I will use its id fa77. If I use directly rm, so it will throw an error saying that the container is in the running state. You cannot directly remove a container, okay, when it is running. You need to first use Docker container stop and then remove it. So there is another flag for this container rm, that is forcing a container to be removed if even though it is running. Okay, if you want to know that flag, just get help section of that command, and here you will see that -f is that command. Okay, so Docker container rm, and I will supply -f, so this will forcefully remove a container. Okay, so even though it is in the running state, it doesn't matter, it is going to just remove it. Okay, so this is how you remove the containers. Okay, now we will talk about some special cases. Okay, so what are those special cases? So we understood that we can simply use Docker container run to run a container. Okay, And this time I will name the container something like OS. This time let me start the Ubuntu latest container. So this is the most important image, not because of its usefulness, but this requires very special commands to be supplied. Okay. See, I started the container, okay, based on Ubuntu image. If that Ubuntu image is not available, first it will be pulled from Docker Hub, then only it will be the container image will be created. Okay. But when I started the container, it did not give me any container ID. Okay. If I look at the all the stopped and running containers, I can see that, just a second, I can see that the container which is based on Ubuntu latest is exited. Got it, right? Understood, guys? But we did not kill it, right? We did not do anything. Okay, it simply exited. Okay, let me see if I can fix it by running it in the background mode with -d. Okay, and the name of the, because OS is already taken, so let me give it as OS1. And then a container started and its ID got printed. So let me do docker ps-a again. Okay, so do you see that it is still failing? Okay. Clear, guys? It is failing. Why it is failing? Okay, it has to do something with the process inside it. Okay, if you inspect the image, okay, so like docker image inspect Ubuntu latest. If you look at the image, so this image has no entry point. There is only one command. So the command is nothing but it is just starting the bash process. Okay, so this is the main culprit here. So when you have a bash process, right, running inside a container, so you have a container image, the container image has bash as the starting process. So the bash has special requirements. Okay, when you run this command, okay, it needs to flag -i and -t. Okay, so together we call it as -it. Okay, so -it, is the requirement for all the processes that, like bash processes. -i means interactive, -t means pseudo terminal. So the reason why it is required is, okay, you are starting this particular container, okay, from your local machine. Okay, so this is a bash process. Bash means it is a terminal, right? Correct? So
Yeah.
terminal needs input, right, from the keyboard. And also when terminal gives you some output back, it also has to show it on our monitor, right? Correct?
Yeah.
Okay. So this bash process, when you are starting it on your machine, well, this bash process expects you to provide it the interactive input and also the pseudo terminal access, so that the bash process can take the input from your keyboard and also return the output and show it on your local terminal. Okay, that is the pseudo terminal. Okay, so when the bash doesn't get these two accesses, the bash process usually fails. Okay, that is the special requirements, which means when I so let me first delete all the containers. Okay, so docker ps-a, I have all the containers which are running and stopped. Okay, uh, if I have to get only the container IDs, I can use -q, which I already said last time. -q will quietly display all the the IDs of the containers running and failed. Okay, running and stopped, because I've used -a. Then I will use docker rm-f, okay, or docker container rm-f to forcefully remove the containers. But I have all the containers ID here. Okay, uh, I want to provide that complete data as an input to rm-f. So I will use this command. Got it? Any questions on this?
No.
Okay, so this will take all the container IDs which are running in stopped, and it will provide to rm-f, which will basically delete all the containers. So now I don't have any containers. Okay. Now let's look at running this, this Ubuntu container again. So this time I will not use any names because I have to end up giving separate names for everything. Okay, I'm directly running it, but this time I will give -i and -t as the. Guys, please mute yourself.
No, me join Lenny. Me.
Okay, so what I'm doing is I'm just providing interactive terminal, interactive input and pseudo terminal access to Ubuntu latest. Okay, so am I starting in the foreground? No, right? Correct?
No, but you are
Guys,
saying interactive, right? So it should be
mm,
in foreground only.
foreground, but I'm not starting in the daemon because I did not use -d here. Okay. Now when you start this as a container, so what did you see now?
Directly entering into the container.
Yeah, so here it opened the bash process in the container. Okay, so bash is like a terminal. So whatever you're seeing is the terminal inside the container. You can do ls, you can see the complete Linux file system of that particular container because that is a container. Okay, got it, guys?
Yeah.
Okay, if I do exit and do docker ps-a, you will see that the container got exited because when you started the container, it started its initial process, that is bash, and you exited from that process, which means you killed that process, which ultimately killed the container. Okay, is there any other way which I can exit from these sort of processes without killing them? Yes. So on your keyboard, just press Control P and Q. Okay, so it is Control plus P plus Q. When you do Control PQ, you're actually exiting from that particular container without actually killing it. Okay, you can see now the container is in the running state. Okay, not only this, you can in fact run your container by giving it interactive input and all in the daemon mode as well using -d. This will also work. You can see that the other container which I just started, it is in the running state. Okay. So this is about Ubuntu container. Now we will talk about how to go into the container and all that stuff later. Okay, so let me just talk about other two commands. So let's say I want to know all the processes running inside this particular container. Okay, so there is a command called docker container top. Okay, docker container top. Okay, and I have to give the name of the container or ID of the container. Let me give 5370, which is this container. Okay, you can see that the process running inside the container. This container is bin by bash. Okay, it is running with the container with PID of 2874. Okay, so what is this 2874? Is it the PID correspondent to the container, the process running inside the container, or it is the equivalent PID on the machine? So we said that the host has access to all the processes running inside the container, right? But we also said that the processes running inside the container will start from PID of 1. But why it is not PID of 1? Why it is 2874? Any idea? So this PID which you are seeing, it is not the PID of the container. It is the PID that your host machine is seeing. Clear? Understood,
Okay.
guys? Okay, so this top command, you're not directly running it as you usually do on Linux machine, right? Like top command. Okay. Because when you want to run top command inside the container, you should go into the container and then run the top or ps command. Okay, so what will happen if the top or ps command is not available in the container and you're unable to see the processes running? That's the reason why Docker came with its own top command. Okay, so from outside only you can run Docker container top, giving the name or ID of the container, and you can still see the processes running. That's another advantage. So you also have other command known as stats. Okay, so this stats will show you the real-time CPU and mem usage of your particular container. Okay, this is the stats for your container. Okay. Now we have other examples. Let's say, what are the other things I have? I have some demo examples I wanted to show you. Yeah, so this one, Docker Hollywood. So this is not exactly, a great Docker image, but this is, uh, you can customize this image because already there is a Docker file involved. Okay, so they created a custom image by taking Ubuntu 18 as the image. Okay, and they already have Dockerized this application, and it is available in the Docker Hub. So what they are actually asking you to do is, they're asking you to run it by giving the interactive input and the sudo terminal access. So this -rm, I'll talk about it little later. Probably I'll cover it today itself. And this is the name of the image. Okay, so let me just copy the image and simply run it. So Docker run -it, that's the minimum requirement. So they wanted it to run it in the foreground only. Okay, so this is a special image. It will just show you that hacking kind of an animation, nothing more than that. Okay, I just wanted to show you. So why we run applications in the foreground? Because if you want to see the logs or how the application is running, okay, we ideally run it in the foreground. Okay, so this is just some animation that it is just showing. Okay, got it? And I can just press Control C. Okay, to stop that process, and then I'll simply click on exit to exit from that container. Now if I do docker ps-a, okay, I can see, okay, that particular image, the container got exited. So that is one thing. Okay, so anything that requires, as I already said, interactive input and the TTY access, always start that container using -it. Okay, that is one thing I wanted to show you guys today. And after that, yeah, so let me talk about logs command and why this is required with this simple example. Okay, so what this Docker image does is, okay, so it will just print your clock. Okay, so it will just display the time. And here, if you see, I am running it in the foreground mode. I did not use -d, okay, to detach. Okay, I'm just going to run it in the foreground. So it will, start. Okay. So first image will be pulled. Now you can see the particular process inside the container is actually trying to print the UTC time. Okay, every second. Okay, since you started it in the foreground, it is actually running like this. Otherwise, if you start in the daemon mode, it won't print all the things like this here. Okay, now let me first kill it by pressing Ctrl C. Docker ps-a. Now the process we started in the foreground, if you try to press Ctrl C or exit, the container will be exited. So there are a lot of containers now you can see getting accumulated. Some are running, some are in the failed state or stopped state. What I'm going to do is I'm just going to remove all of them using this command. Okay, I removed everything. Now what I'll do is I'll run the same command, but this time I'll use -d to start it in the daemon mode. So Docker ps-a. to get all the running and stopped containers. You can see that one of the container is in the running state from 4 seconds. Now I want to see all the logs of the container. Okay, so there is a command called docker logs. That's the usual short. The long form of the command is docker container logs. Okay, but ideally you end up using docker logs command anyways. And if you look at the help section, okay, so docker container logs expects you to give the container name or the ID, and then there are some options. Okay, you can get only the last n line of lines, like I want to print only or see only last 2 lines. I can simply say -n space 2. Okay, -n is short for -tail. If you want the timestamps, I can use timestamps. If you want the follow log, I can use the follow log. Okay, so all these are there. So what I'll do is, I'll just start with the normal log, that is Docker container logs, and I'll give the name of the name or ID of the container. So this is not a real log. So this is actually the log file which is being printed. Okay. If you want to see the real log, that is the follow log, use -- follow or -f. So this way you will see the real log. But you have this huge log, right? So if you don't want to see all this complete log, okay, just press Ctrl C and then see all the container logs using -- tail. Let's say I want to see only last 2 lines of the log for this 1F AA container. Then you will see, the last 2 lines getting printed automatically. Okay. That is one thing. If you simply press 1, it will just show you the last 1 line. Okay. And there is also -- timestamps, right? If you get the help section of the logs, there is -t. That will just show you the timestamps. Okay. Just put -t somewhere here or after -f. It is up to you. Now, you can see with the log, you also have the timestamps appended. Okay. So this is the log of that container. Okay, because you started it in the background mode. Got it, guys? Understood? Any questions? Yes, any questions? No?
Yes, Vikram, I have one doubt about the command docker run and docker container run. So what is the
Same.
difference?
Actually, in older days, they never used to have this 3-part command like docker container run. They used to simply say docker run. Okay, so in order to differentiate between various objects like in containers, images. Okay, so ideally, if you do docker inspect and give the name of the container, Docker will know that it is a container name. If you give docker inspect and name of the image, it will do docker image inspect. Okay.
Okay.
But to avoid the confusion, you have that extra term, like whether you're working on containers, whether you're working on images, you have that extra term.
Vikram, how
Okay.
can we check the process ID 1 of the container?
Yeah, so that I will just talk about it tomorrow because I need to talk about docker exec command. Okay, to go into the container and run that command. Okay, so that is little bit tricky. I'll tell you tomorrow, but let me first complete the other parts. Okay, some basic ones. Okay.
Yes.
Okay, so let me run the same command, same container based on this clock, and it will just start to, run that process in the foreground because we did not use -d. Okay, so in the next terminal, what I'll do is, I'll just get that process ID, the container ID of that container. Okay, it is F103. Okay, so if you want to pause a container, pause the processes running inside the container, it is docker container pause, and then I can use the container ID like this. Okay, you can see here the process stopped here in the other terminal because I took the container ID and then I just did docker container pause for this container. See, the process is stopped. Okay, and then I can resume this by simply doing unpause. Okay, now you will see that the process started again. Okay, clear? So that is pause and unpause. Okay, and coming to the other examples, so you have the commands to override default CMD and entry point. Okay, I'll talk about it now. First, let me talk about how to override the default CMD and entry point. Let me delete all the containers. Let me clean up all the containers. Okay. Yeah. So let me show you Docker container run hyphen help section again. Okay. So if you see Docker container run command, right? If you look at it closely, so we have Docker container run. All the options like -d, -i, -d, volume mapping, everything goes here in this option. And we know that we have image here, the name of the image. Okay, so when we ran all the commands like uh, this command, okay, so we only stopped at the image name. Okay, the last part is image. But after the image, if you look at the container run syntax, so you can use command. Okay, what is that command? Okay, so let me show you. So every image comes with a CMD and entry point, right? That's the default, right? Correct?
Yes.
Right? So the CMD will be decided when you create a container image, and using Docker image inspect, you can see it. So when you're running this particular, this container based on this image, it usually starts its default CMD and entry point. But I can override it by simply providing extra command. Okay. So for simplicity, I'm just taking it an Ubuntu image, Ubuntu latest. So for Ubuntu latest, the process is always bash. Okay. Now I can override that process by simply giving extra command like this. Now your Ubuntu latest, usually it runs bash, now runs hostname as the starting command, not your bash. Okay, this is how you override. Okay, because you can see here, we can override that particular command by giving extra command after the image name. And of course, you can also give some arguments. Let's say instead of host name, I wanted to ping 8.8.8. Okay, so this whole thing now becomes the command CMD because you are overriding it. But of course, at the Docker container level, this will be taken as CMD, and these are just like arguments to the CMD. But this overall is the CMD. Always remember, the default CMD can be changed after the image name. It is not the entry point. It is nowhere related to the entry point. It is the complete CMD. Then how do you override the entry point which is available in an image? So there is an extra flag called hyphen entry point. Okay, you should use this. Okay, going back to our earlier discussion, let's say I created my own Ubuntu image. Okay, my Ubuntu latest. So in that Ubuntu latest, I have sleep as the entry point. Okay, and then CMD as set to 3000. Okay, got it?
Yes.
Okay, so if I simply run the container like this, it is going to run sleep 3000. My requirement is this particular container should sleep for 5000 seconds. So what should I do? Hmm?
5,000.
Simply put 5,000. Okay. Because you are overriding only the CMD. Entry point stays the same. That is sleep. So now the overall command will be sleep 5,000. Okay. Clear? Guys, clear? Okay. Now let's say instead of sleep 3,000, I need ping 8.8.8.8. Okay. So CMD by default it is 3,000. I can override it to 8.8.8. But I mean I can do it here. But what about this ping entry point? So I can't override the entry point like this. So I need to use other flag called entry point, where the default entry point is sleep. Now I'm overriding it with ping. Okay. So what did I just do? I overridden the entry point and also the CMD. So which means ping 8.8.8.8 will be my latest, the overall starting command for my container.
Okay.
Okay. Let me show a simple example.
So
Yeah. Tell me.
can you go back to that notepad? Yeah. So minus entry point is options is one of the option. Is that correct?
Correct.
Okay. Okay.
Always remember options are like flags. They come with single hyphen or they will usually with double hyphen.
Oh, okay. Okay, thank you.
Okay. Now let me run. So this time I'll directly use Docker run only. I won't use Docker container run. Okay. So if I just start the Ubuntu, Ubuntu latest, so it will only start the bash process as we already know. Okay. So this time I would like it to just run the host name as the command. Okay.
Can you just increase the font size, please?
Okay.
Oh.
So it printed some ID. Okay. What did it do? It printed some ID. Now if I do docker ps-a, you can see here it exited. This is the important one. Okay. You can see here it is now running hostname as the command because we have changed it, right? Okay. Similarly, instead of hostname, by the way, which hostname it has printed? That is important, right? Which hostname it has printed?
Container.
Containers hostname.
Yeah.
Okay, because we didn't come to this command called exec to go into the container and see its host name. We'll see that tomorrow. But this host name is actually the container's host name. Okay, if you're still not sure, simply do ls. Okay, so what it is doing? It is doing ls inside the container and then it is just printing the ls output. Okay, but these commands are all short-lived commands. Okay, they will complete within seconds. That's the reason why your container goes always into the exited state. As I already said, container should always be in the running state if you are running your application. Okay, so if you're simply doing ls and all, it will exit. Okay, once I exit, it becomes a headache for me to go and remove the container like this, right? Every time. Okay, so here what I'm doing is I'm individually deleting them by giving the container IDs like this. Okay, so now both the containers are deleted. Okay, it is a little headache, for me to manually go and delete the, containers. So there is another flag called --rm, specially for this purpose. Okay. So what does this rm --rm will do is, if a container exits due to any reason, okay, it will immediately remove it. Okay. If your container is running, it won't do anything. But if your container exits and if your container is in the stopped state, automatically this container will be removed, okay, from that list. Now you see here, I just added -rm, and we know that ls is a very small command, like it will run just for a second, and the container goes into stop state, and then -rm will make sure that the container is deleted as well. See, the container started, but if you do ps-a, you won't find that container because it is removed, automatically removed by -rm. Okay, clear guys?
Yeah.
Clear. So Vikram, like we can change the mm,
Yeah, tell me. I'm
we
hmm,
uh, am I
we can,
audible?
yeah, you're audible.
We can change this ls.
Hmm.
What is this?
Command.
Yeah, the command, the entry point. We cannot change this both in image. We
Yeah,
can
we can change. See, if let's say your Ubuntu image has only CMD that is set to bash. Okay. So
Okay.
doing ls, I'm just overriding bash. Let's say I wanted to ping 8.8.8 Google DNS servers. Okay. So I can simply give it like this here itself.
No, but we are running the container now. We are running and changing the both these things. But
Hmm.
what I'm saying, like if I have one image and I have get it from the Docker Hub, in
Hmm.
that image I inspect and find out the command, like Python 3
Hmm.
is the
Hmm.
command. I
Hmm.
know when I run this thing, it will exist its stage
Hmm.
after doing
Hmm.
Python 3.
Hmm.
But within that image, if without running, I cannot change this entry point and command thing, right?
Yeah. So because images are immutable, your container cannot change it. Only thing you can do is you can configure your container when you
Nee,
start it.
when I customize my image,
Hmm.
so there is a way to override
Yeah, correct.
within
There
the
is an
within the
override.
okay,
No, you
okay.
can't see. You
Mhm.
can't change that Python base image which you have taken. You can create a new image by taking that Python as the base image, and then you override in your own custom image. Getting it?
Yes, yes, okay. But we are not doing this is not that thing, right?
No,
We are
this is
running
all
the
it. So we are actually giving all these options when you're running the container so that your image stays the same.
okay,
Okay. See, this Ubuntu has a CMD, and then I'm just giving this whole thing as the CMD replacement. Okay, so then what will happen in this case is, you can see here, the ping itself is not there in the container image, in the Ubuntu image. Okay,
hmm,
so I can't run ping. Then what I should do if I need ping or anything else, I have to create my own container image. Okay, so for example, so here there is there should be one image, Docker funny box. Just a second. Yeah, I think that's the one. Docker funny box. Yeah. So here, this is a generic image. Okay. So if you simply run this image, it will just show you all the commands and various other options supported. Okay. So this image you can supply your own CMD replacement, and then it would run something else. You can provide some other CMD, it would run something else. Okay, got it. So
okay,
they created a generic image, but here that that CMD you can override because they have given a lot of other CMDs. Okay, so using that you can. So let me just run this and show you. All these are available in the text document I'm going to share. Okay, now why they have used hyphen RM is because this one will just print some information and it will exit, or it will run some short process and it will exit. So they want the container to be automatically deleted. That's why they gave this hyphen RM. Okay, you can see these are various options you can have. Okay, which means when I'm running the previous image again, I can just simply say SL probably. Okay, so they are actually giving some user input, taking some user inputs and all. That's fine. Okay, so next time what I'll do is I'll simply say probably this YouTube. That is the argument. That is the replacement they are expecting. Again, this won't run because I think it needs some UI access and all. This YouTube won't run. Let me just take another example, like BB or something like this. Some options they are giving, some sort of application. Okay. Okay, so it is displaying some music information. Okay. Any questions, guys? So that is how you configure. Then I can remove it forcefully using docker rm-f and your container ID. Okay. Any questions? Hello. Guys, can you hear me?
No. Yes.
Okay. So now let's close the session with one, one small topic, that is the restart policy. Okay. So what is this restart policy does is, so let's say your container is exiting due to some issue. Okay. Probably you're running a Jenkins container and Jenkins container exited due to some issue. So what will happen if it gets exited? Will it automatically come back to the running state again? No, right? So once the container stops, it will be in the stopped state unless you go and manually start it, right? Correct? Understood, guys. But
Yeah.
what about running some critical applications and if that application stops? So should you monitor that particular application all the time and manually bring it up? It is not possible, right? So this restart policy controls the restart behavior for a container. Okay, so when you start a container, by default, the restart policy is set to be, uh, no. Okay, so when I'm running docker run, so let me run a container by the name test. I'm calling it as I'll just create the container from the one to latest and I'll simply say ls. Okay, so this ls, if I simply run, it will print and it will exit. Okay, so docker ps-a, you can see that the container is exited and it is not restarting. Okay, because the restart policy is no. Okay, so let me remove this container, docker rm-f test. Now this time what I'll do is when I try to run a container, okay, it can be any container, I will set the restart to always. So what is the meaning of restart always is, no matter the exit status, like, let me go back to the documentation. Okay, so always means irrespective of the container's exit status. Okay, the exit status can be anything. It can be positive exit status, it can be negative exit status. Okay, got it? So irrespective of that state, your container will always be restarted. See, exit can be two ways, right? Exit can be a positive exit, it can be a negative exit. Positive exit means the container completed its operation and it is exited. So should you restart the application in that state, in that condition? Let's say you have a work and you have completed it. Okay, it is a failed status or it is a success status, guys. It is success status, right?
Yes.
So in that case, you should not restart. Why will you restart? Why will you do that same work again and again? Right? So restart always means, even though the container's process exits with a positive exit state because the container finished its operation, even in that case also it will be started. But it should be used with caution because it will keep on restarting the containers even though they are completed. And then on failure, this is important. On failure means only if the container exits with a non-zero exit code. Okay, which means the containers process exited with some issue. For every issue, there is a code. Only in that case, the container will be restarted. Okay. Unless stopped. What is this unless stopped means? It is similar to always. Okay. Unless stopped means when a container is manually stopped by someone. Okay. In that case, it is restarted. Okay. So we ideally use always or on failure. Okay. So let me show you always case. So if I just set -hyphen restart to always. Okay, so the container, created, it ran this command and it got exited. But if you do docker ps-a, you will see the restarting. Okay, clear guys? So it will again restart, but the problem is again it will fail because it will again do ls and after that, it will finish and again it goes into stopped state. Again it will restart, right?
Mm.
Correct. So this is you should not use for these kind of processes that are very short lived. Okay, so for Jenkins and all, because these containers will run forever and sometimes they will stop, so using restart policy makes more sense there. Okay, but if you know that your commands will fail immediately or they are very short-lived processes, don't use restart policy because they keep restarting and they will put load on your. On failure means only when there is a failure in the process. Okay, when the process fails with some negative status code, in that case your container will be restarted. Now you see here. So we have this command. So here they are starting a container based on this Redis image and they're using restart policy set to unless stopped. So the following command starts a Redis container and configure it to always start unless the container is explicitly stopped or the daemon restarts. Okay, in this case, if you stop a container, it will be always restarted. Okay, and yeah, that's it. We don't have anything else. That's the restart policy. Okay. So we still have some more commands like port mapping, exec. Yeah, so there are a lot of commands still available. We'll see them tomorrow. Okay.